Alright, today we're looking at amplitude changes, so we're having a look at what happens if we multiply our trig function by a factor. Now what that does is it changes the amplitude. So remember, your amplitude is the distance between your horizontal axis and your peak, or your horizontal axis and your trough. Okay, it's the distance between the centre of the function to the peak or the trough. So if we multiply the whole function by that factor, it's going to multiply every single y value by that number. Okay, so you can read amplitude directly from your function. So whatever the number is tells you what the amplitude is, or what that distance is going to be. With our general trig functions, we know it's based on the unit circles, so the amplitude has been 1 so far. So if I change this so that it's more than 1, then it's going to increase my amplitude. Remember, if you get a negative a value, it doesn't change the size of the amplitude in the negative direction, because it's just a distance, it's not a direction. So if you had -2, your amplitude would still just be 2, but it just means it's been reflected in your horizontal axis. So if we do multiply it, it's going to stretch it vertically. Okay, so it stretches everything up the y-axis because we're multiplying all of our y values. So if we have a look at our general sine function and get our exact values that we had a look at graphing the other day. Now if I change my amplitude to 3, so I'm multiplying the whole function by 3, just means each of those values gets multiplied by 3. Okay, each of them gets multiplied to generate my second set. So if I was to sketch it on an axis, I've got my general sine function sketched in black, and then in green we've got 3 sine of x. So we can see it's been stretched up and stretched down so that we've got that vertical stretch. Okay, so we can see it's made it taller and a little bit slimmer. So have a go at doing question 1, 2 and 3. You're doing some sketches. Hopefully you've got some graph paper there that you can do it with. If not, do it as neat as you can in your book, and then come back and have a look at the amplitude changes with a translation. So the next part is combining what we did yesterday with our vertical translations and what we've done today, which is our amplitude changes. Okay, so your amplitude changes where your peaks and troughs are going to be, and then your vertical translation, or what you add or subtract on the end, changes where the centre of your function is. So before, the centre of our function was the horizontal x-axis because we were only adding or subtracting 0, so nothing was changing there. Whereas if I add 1, then it's going to move my whole function up, so the centre of the function moves up 1 unit. So you still base it on the information that you've generated before with your exact values. So if you had 3 sine x, we generated those earlier. Then for each of those values we add 1. Okay, so for 3 sine x, for 3 lots of the sine of 0 we had 0, and we had to add 1, so we've gone up 1. 3 lots of the sine of 90 degrees gave us an answer of 3, so we've also got to move it up 1, so it becomes 4. Okay, so I like to sketch the horizontal dotted line in to help me with my sketch. Okay, I plot my values in about that line, and it helps with the nice curved shape. So have a go at question 4. It's combining your amplitude changes with your vertical translations as well.